everyone. Today we're going to discuss the issues surrounding existing material review board processes and how NLign Analytics can provide a solution to these problems. First, let's examine the key challenges faced in current MRB processes. MRB actions are costly. They can take days or even weeks to resolve, which leads to missed delivery schedules and potential delivery penalties. This, in turn, results in increased inventory and material costs, as well as unacceptable first-pass yield. Inefficient documentation. Our analysis shows that there are significant costs associated with just documenting discrepancies and performing the preliminary review. Moreover, the current methods used to document these discrepancies do not generate data that is easy to use for disposition reuse or to drive process improvement. Finally, dependence on expert knowledge. The current processes also rely heavily on expert knowledge. The data that is generated is not easy to use, requiring more time and resources to realize its value. Let me share a scenario to illustrate the challenges with existing documentation processes. An engineer, John, is working on an aircraft inspection report. He receives the documentation, which includes a combination of free-form text descriptions, manual measurements, and PowerPoint attachments. John finds it difficult to parse and understand the disorganized information in the report and can't accurately visualize the discrepancies on the aircraft. Frustrated, John has to walk 30 minutes to the hangar where the aircraft is being inspected to verify the data in person. This not only wastes valuable time, but also disrupts the workflow of the entire team. This scenario is a common occurrence in the industry, highlighting the inefficiencies and frustrations associated with traditional MRB documentation processes. These current processes involve manual measurements, free-form text descriptions, and PowerPoint or Word attachments, often leading to incomplete or inaccurate documentation, causing time-consuming back and forth between inspectors and engineers. Duplicate analysis can also occur due to the difficulty in finding information in unstructured text, and recurring discrepancies may go undetected. To improve the MRB process, we must address these issues and strive for the fundamental goal of reducing discrepancies and MRB actions. Our solution to these costly processes is NCheck, a 3D inspection data capture application. With NCheck, discrepancies are positioned on a 3D model using various methods such as photo mapping, imported NDI data, or drawing directly on the model. This visual representation makes it easier to understand and communicate issues. Model interrogation features allow for efficient access to part numbers and criticality codes. NCheck also offers structured data capture based on defect type, configurable to individual customer requirements, and it can ensure completeness and consistency by enforcing mandatory fields, checking for valid values, alerting the user to data that is out of an expected range, and providing automatic calculations. Now, let's revisit John, the engineer from our earlier scenario. After implementing the NLign suite of tools, John's experience with the MRB process has significantly improved. He's thrilled to see all the data he needs to make a disposition visualized on the 3D model. The system enables him to access historical dispositions, analysis, and associated part information all in one place. One day, John receives a new inspection report. Instead of going through pages of text, manual measurements, and attachments, he simply opens the 3D model in NLign and searches for the relevant data. The model shows all the defects and discrepancies mapped accurately onto the aircraft structure. John can now quickly identify relevant precedents and review all necessary data without searching multiple locations, saving him valuable time and effort. This new approach has not only made John's job more manageable, but it has also significantly streamlined the MRB process and provided reusable data. The 3D visualization of defect interactions and the ability to access a list of other discrepancies associated with serialized parts have provided a more comprehensive and efficient decision-making process. NLign Analytics enhances data reuse and part state awareness by visually displaying historical disposition and analysis on the 3D model, allowing engineers like John to quickly identify potentially relevant precedents. This feature accelerates the MRB process with a 3D graphical search and 3D visualization of defect interactions, showing all defects on the part simultaneously. Users can also access a list of other discrepancies associated with serialized parts, and view details associated with each discrepancy, promoting comprehensive decision-making. With the tools provided by NLign, John the engineer can now collaborate more effectively with inspectors and other engineers to optimize processes and prevent future discrepancies from occurring. By analyzing the output from the spatial clustering tools, John can identify the root causes of recurring discrepancies and make data-driven improvements to their processes. For example, John and the manufacturing engineers identified a specific manufacturing step causing a recurring defect. They shared their insights and collaborated on a solution to address the underlying issue, leading to fewer discrepancies and a reduced need for MRB actions. Similarly, John can use the insights provided by NLign to work closely with maintenance teams and refine their procedures, ensuring that issues are detected and resolved before they escalate into more severe problems. NLign Analytics empowers users like John and manufacturing engineers to work together using spatial clustering tools that highlight problem locations and enabling them to drill down into these clusters for a better understanding of the issues. Visualization of spatial clusters facilitates root cause corrective action efforts, and the 3D environment allows more shop floor decisions on discrepancies. Furthermore, the system helps detect repeat use-as-is dispositions that indicate the need to update technical requirements, which drives continuous improvement in manufacturing and maintenance processes. Now let's take a look at a real-world case study to understand the impact of the NLign suite of software on MRB processes. Northrop Grumman conducted a time study to evaluate the effectiveness of NLign in their internal MRB process and found an overall 33% reduction on disposition time. The time study revealed that the documentation and preliminary review stages of the MRB process experienced a 23% time savings, and engineering disposition saw a 10% time savings. This case study demonstrates one example of the significant improvements in MRB efficiency that can be achieved through the implementation of the NLign application suite. In summary, the NLign application suite offers several benefits that address the shortcomings of traditional MRB processes. First, complete and accurate 3D documentation reduces time-consuming back and forth between inspectors and engineers and enables data reuse. NLign can also reduce the number of future discrepancies and MRB actions by equipping engineers to implement root cause corrective measures and update technical requirements. The digital environment also enables decisions to be made directly on the shop floor based on three-dimensional data. Finally, NLign's interface, analytics tools, and 3D visualization reduce reliance on expert technical knowledge, improving the ability of other team members to find relevant data required to make decisions. One of the most significant benefits of NLign is the ability to capture a digital twin for every individual aircraft from manufacturing through in-service. This digital twin not only provides a comprehensive record of the aircraft's history, but also serves as a valuable tool for predictive maintenance, fleet management, and process optimization. By tracking and documenting each aircraft's specific characteristics, discrepancies, and repair history, the digital twin has become an invaluable asset for maintenance teams, engineers, and operators. It allows them to access a wealth of information on each aircraft, enabling data-driven decisions and more efficient maintenance planning. Moreover, the digital twin can be used to simulate and predict potential issues before they occur, allowing for proactive maintenance and minimizing the risk of unexpected downtime. This level of detail and accuracy is only possible due to NLign Analytics' 3D documentation capabilities and the ability to store and manage a wealth of structured data associated with each aircraft.